Hi, in this video I'm going to explain to you differentiation, and basically we're going to start off with derivatives of trigonometric function. Now the first two functions that comes to mind is the graph of y is equal to sine x and the graph of y is equal to cos of x. Now we know that the graph of y is equal to sine x will look something like this, and that of cosine x is going to look something like this. Here we got this is 1 and minus 1, 0, 0, minus 1, 1. Maximum, minimum. When we talk about graphing software, now there's graphing software, that has been used to draw graphs of sine x and cosine x, but we still need to learn how to draw them. Okay, and the gradient function, we're going to come to that in a moment. Normally the gradient function for sine will surely go like this. It's going to start off with 1, it's going to go like this here, runs along, cross here and there, where this is going to be equal to pi upon 2, and here you're going to get 3 pi upon 2, and that of the cosine function will go something like this. Like this, okay, and of course the 2 pi here and pi here, and then you got pi upon 2 here. Now for the purpose of this study I'm not going to go into detail about how you derive the gradient function, how you derive y is equal to sine x. What we're going to do, we're going to just apply, we're going to use we're going to remember that if you have y is equal to sine x, then dy by dx should be equal to cos of x. Similarly, if you have got y is equal to cos of x, then dy by dx should be equal to negative sine x. Also, if y is equal to tan of x, then we have something like dy by dx is equal to sec square x. I'm sure you're very familiar with this. Okay, so immediately we're going to look at some examples. We're going to make this study, this course very smart and short and very substantial. If you have got, like, say, y is equal to sine x, and I'll tell you to find dy by dx. It's not going to be very difficult. You just have to say y is equal to 2 cos of x. So that's the answer. If you've got, say for instance, for part B, y is equal to x cos of x. Now we're going to use product rule. Why? Because this is of the form y is equal to uv. So you got, if you were to differentiate this, okay, you have u is equal to x, this is u, and this is v, and the v is equal to cos of x. So du by dx is equal to 1, dv by dx is equal to negative sine x. So v du by dx plus u dv by dx, that's going to be equal to dy by dx, which is u dv by dx plus v du by dx, and that burns down to dy by dx equal to u dv by dx is negative sine x times x plus v du by dx is cos x times 1, which is then cos of x. So that should be your answer to this part of the question. So we're going to move on to more examples. For instance, if you were to, let's say for example now we want to talk about the derivatives, okay, of, say for instance, sine ax plus b. I'm sure you will remember that this has got something to do with chain rule. So ax plus b here. So if we differentiate sine, okay, so we can say let, alright, if you want, y is equal to sine of u, where u is equal to ax plus b. So you can find dy by du if you want. So dy by du is going to be equal to cos of u, and du by dx is equal to, differentiating all of that, should be able to get a. B is a constant, it goes down to 0, ax differentiate, you get a. So then you're going to use dy by dx is equal to dy by du times du over dx, and this is going to be equal to dy by du, which is cos of u, times du over dx, which is a. Alright, and therefore you've got then a cos of u, so that's dy by dx, and finally it's going to be a cos of u, and u was found to be, we actually said that u was ax plus b. So that's how we go about and derive, get the derivatives of a function like this. So I'm just going to take a clear example for you, right? Sorry about that. Okay, didn't realize it was not quite in view, and this is what we were talking about. Alright, so let's say for instance you've got 2 sine of 3x, and I want you to find ddx 2 sine of 3x. So that's the question. So if you differentiate this, how are you going to do this? Alright, so you're going to say ddx, sorry, 2 sine of 3x should be equal to 2. Then what you do, first of all, you differentiate this core here. This is 3x. So differentiate 3x, you're going to get 3, and then times differentiate sine x, you're going to get cos of x, but it is 3x, so cos of 3x. So we've got then 6 cos of 3x. Right. Let's take another example. This is done. Let's say I give you 4x tan of 2x, and I tell you to find ddx. Okay, differentiate with respect to x, okay, for this. Now this is for, pardon me for my handwriting, and if we were to differentiate this, okay, we can see that this is u and this is v. So we're going to apply again product rule. Very important, you must have learned product rule quite a lot, done quite a lot of questions and examples there. So what we're going to do, we're going to keep the u. Okay, what is product rule? We did say it was somewhere here, product rule, there we go. This is our product rule, okay. So you're going to keep the u, you're going to differentiate v. So let's keep the u. If you keep u, you're going to get, okay, if we keep u, we're going to get 4x. Let's keep the u, so we got 4x, differentiate tan of 2x. So that's going to come to sec square 2x. But to remember, you need to differentiate the core, so you multiply by 2. And then this is u dv by dx, u dv by dx, plus v du by dx. So v, now we're going to keep the v is tan of 2x, okay, and then you differentiate u, and that's going to become 4. So what we have, 2 times 4 is 8x, here 2 times 4x is 8x, sec square 2x, plus 4 tan of 2x, and here we are. So this is d dx 4x tan of 2x. Right.